Hi, welcome. In this video, we will solve problem Subtree of Another Tree asked by companies like Amazon, Microsoft, Facebook, and Google. Now let's check one more fundamental problem on binary trees. Okay, we have solved a similar problem in the last problem that we have solved. Okay, that was of same tree. This problem is like I will say 80-90% similar to the last problem that we have solved. Okay. So if you have solved the last problem, I want you to go ahead, give it a good shot. Okay. Try it or see if you are able to come up with answer or not. Okay. If you are not able to solve it, then you can check this video. Okay. So let's check this. So we have a subtree of another tree. So given the roots of two binary trees, the root and the subroot, right? So we have given subroot and root. Return true if there is a subtree of a root. So basically, what is a subtree? So basically, here they have mentioned a subtree of a binary tree is a tree, right? So that's a tree that consists of node in a tree and all the nodes descendants, right? So these are all node descendants. The tree could also be considered as a subtree of itself, right? So this tree, the whole tree can also be considered as a subtree, right? This portion, you can say this is also a subtree, right? Even a single node can also be represented as a subtree, right? That is also a subtree. Basically, it should have nodes and its descendants. Okay. So basically, this was a subtree, right? And now we need to find that we have given one subroot. So is subroot is a subtree of this tree. Okay, that we need to find. If it is not, we need to return false. Okay. So here we can see, right, this subroot, yes, that's a subtree, right? This is a subtree of my this binary tree, right? So here I will return true, right? So you can see this portion is exactly equal to the portion. Sorry, this portion. Okay. So now let's see. Now let's see how we can solve this problem. So let me again complete the diagram first. So we have 3 and we have 4 and we have 5. Okay. And then I have 1. Okay. And 2. Okay. And we have subroot, that is 4. We have 1 and okay. So, okay, one question that we have solved, that was same tree, right? So when we have one node here, okay, and 2 node here, 3 here, then we were simply calculating that it is same or not, right? If they are same or not, that means identical or not. So this was P and this was Q. I was checking the values, right? Then I was moving to the left, again checking the values if they are equal. So here both the things, right? Because needs to be identical, both the things should be equal, right? First of all, we were comparing with well, okay, and if they are equal, we were comparing the left node and we are comparing the right node, right? So this was the condition. First, well, like well is equal, then we will simply jump to the left node and the right node and we will compare. But here is not the case, right? See, I will check 3 and 4, right? I will start with the first one, right? Because this subtree can be here itself. So I will check with the first node, okay? And I will check if the values are equal. So values are not equal, right? So if the values are not equal, should I directly return false? No, right? In this condition, no, right? Here in this condition, we will return false, false only when we will search all these nodes, right? Right. If there is no possibility of finding answer, then we will return only false. Otherwise, we will check all the possibilities, right? Now, 3 and 4 is not equal, right? The values, the nodes are not equal. So what I will call the left node, right? I will call the left node and here I won't move, right? Why should I move it here, right? This is not equal. So that means either can be in the left portion can be my answer, or maybe in the right portion can be my answer, right? Maybe here I can find out the trick, right? So remember, either in left portion or in right portion. So now from end condition, right, we'll move to or condition. Okay. Either my left node can have a subtree or can right node can have a subtree. Remember this thing. We will use it. Right. Then I will move to the next portion. Okay. And I will check. So do they have equal values? Yes. Now, once they have equal values, what I will do, I will call one function, right? I will call the same function, right? What the same function that we have used, our same tree, right? I will call that function, and that will tell me is these two trees are basically same or not. These two trees are basically same or not. So suppose if it is returning true, so yes, these are same, right? If it is returning true, okay. Suppose if it is not returning true, right? Suppose let's take the first case of false. If it is not returning true, then I will check with this one. I will compare 5 and 4, right? They are not equal. Simply, I will simply, what I will do, I will leave that, right? And I will return false, right? But here we are returning true, right? So any one of the condition is true, right? Left node, we are getting an answer of true, but in right node, we are getting an answer of false. In left node, we are getting an answer true. So we will return true only. Okay. So we will return true. But there is one problem. I will discuss it later. But let's see this case. When you have this 3, 4, 5, and suppose 4, 1, 2, okay, and you have one this node, right? And this is your subroot. Are both are equal? Are both are equal? Like, or I will say, if this the subroot is a subtree of this tree, this subroot is subtree of the tree. No, it's a false. Why? See, why I'm saying subtree, right? Basically, this is the root from this root node, right? These nodes are connected, right? So if I'm calling this one, if I'm calling that these two are equal, right? This root is also equal. This is a subtree. That means I'm calling that this 0 is also there, right? This 0 node is also there. No, here 2 left node is null, and here 2 left node is 0. So basically, if you detach, right? If you detach from it here, right? These two are not equal. So if these are not equal, you can't say that this is a subtree. Okay, that's the thing. Suppose like here it is subtree. Why? Because if you detach it from here, these two are equal. These two are completely identical. So yes, that's a subtree, right? So remember, even if you are getting equal values, right? You will first compare. You will compare the complete root node here, like if these two trees are equal or not, right? And this will return false because we have checked, right, for this condition, right? If there is something, suppose 0, right, here is null, so it will return false, right? So eventually you will get an answer. Okay, one thing let me tell you, okay, that you will miss if you are checking only values. Basically what I was saying, that you have checked with 3, right? 3 and 4 values are not equal, you move to the left portion, you checked 4 and 4 both are equal, right? And what you are doing, you are simply moving into the subtree, right? That same tree or not. Then suppose there is one condition that you have, suppose one node 2 and one more left node 2, and you are comparing with only single node 2. So that's a subroot you are comparing. Yes, so this is your subroot and this is your root. You are comparing with this one. Now suppose what you will do, you will check, okay, right, root value and subroot value both are equal. What you will do, you will simply call the function, right? Same function, same tree, right? And it will return you false because here there is a 2 node, right? But here it's not. So it will return you false. So if it is returning false, will you say that, yeah, that's a false? Because you are getting an answer. No, right? Suppose you are getting a false, still you will check for this one, right? Still you will call the left node, even if you are getting a false answer, right? So you will only return true, right? When you get true, then you only return true. Otherwise, if there is a false case, you will check for other possibilities. You will check for other possibilities, right? So here you will check for left node, and then you will compare with left node with subroot. If these two are equal, then it will return true, right? Then you will return this true to itself, okay? And then it will eventually return true, okay? So let's take out an example, right? Let's take out one big example and let's see how this will work. So suppose we have 3, 5, and let me create it here. The structure 4, suppose 1, 2, suppose, let me this one only, and suppose we have here 6. Okay, and we have one subroot like this one, 4, 1 and 2, right? So basically how I will proceed it, right? How I will proceed it. I will check root and subroot, right? Suppose again, let's take the same example, P and Q. Right? I will take P and Q here, right? So I will just simply check if there is a function. I will directly check, right? If P and Q, I will simply call the function same tree, right? These two are identical. No, it's not, right? So what I will do now, I will call the left node, right? P and Q here. Okay. Now I will, once if they are not equal, right? If this same tree function is returning false, right? If this is same tree returning false, I will call the left node, right? I will call if these two are equal, no, right? I will call the left node, but I am getting null. So if I am getting a null, right? Where, like suppose if your root is returning null, you can directly say false, right? So if you are basically if you are getting a null, that's a step that you can simply move back, right? You can simply move back to the previous solution, right? So you will simply move back. What was your answer? And see, like here, you are not getting an answer. You can simply return false, right? Basically, it's a null, right? Here, my like this node, it's returning me null, and always we will change our root because we won't change subroot until and unless we are not getting the exact value, right? So here, whenever my root is null, root is equals to null, what I will do, I will return false. Okay, but that's not a single false. Basically, we will check for other possibilities, right? So I am getting false from here, right? I will check for right node. That is also null. P and Q, like this is also not equal. So from here and here, false we are returning. So it will return false, right? And here it will return false. So from left node, we are getting a false. Okay. I will check for the right node, right? So my P will be here and I will compare P and Q. Are both are equal? No, they are not, right? Again, I will call the same tree. It will return me false, right? Then what I will do, I will check for the left node, right? Okay, are P and Q are identical. And here, once I give this to a function, right? My same tree function, it will return true, right? It will return true because that's like now the work is of same tree function, right? The function that we just created in the last question, right? Same tree function, right? Because these are same tree. I will simply pass this one and this one. Remember PQ, right? I will pass this one and it will return me true. Now, if this is true, right? I will check. I will check for the right one also because that's a recursion. I will check for the null. Here we are getting null. So from null, we are returning false, right? Now one is true, one is false, right? Remember, I left node or right node. So in any of the condition, if I am getting true, I will say true. So here I am getting true. I will return true only, right? And now you can see from left node here you are getting a false, but here you are getting a true. You see here you are getting a true, and the answer will be true. Like here you are getting true, and the answer will become true. So basically here you are checking with OR condition, right? Any one of it is true, it will be true, right? And if both are false, then only the case will be of false. Okay. So what will the pseudo code of it? Okay, let's quickly see the pseudo code. Okay. So basically what I will do, the function will be is subtree, right? This is my function with given root and subroot. So what I will do, right? If suppose subroot is null, okay, if subroot is null, right? So suppose if subroot is null, can I directly say true? Why? Because if null is the subroot, null is basically null is the subtree of all these trees, right? Because this is also null, this is also null, this is also null, this is also null. So yes, null is always the subroot subtree of the tree. So if subroot is equals to null, okay, I can directly return true. No need to check anything. Now, if my root is equals to null, okay, so here, like we check this condition. If my root is equals to null, what I will do, what I will return, I will return false. Now, there can be one condition that you are saying, if suppose both are null, root is also null and subroot is also null. Okay. So in that case also I should return false, right? Okay. If both are null, no. See, in that case I should return true, right? Because our root is also null and subroot is also null, right? In that case I should return true, right? And here I am checking first the subroot. So can I directly say it will return true? I don't need to check this condition when both are true, because I am stating this subroot is whenever null, return true. So it will take this case also when both are null, root and subroot, right? And I will return false only when root is null, right? So if root is null, so that means you are coming here, that means subroot is not null, right? So yeah, this is how you can tackle that condition. Now, once you read out here, then what will the next condition, right? You will write, you will simply check for the our function that we created, remember, right? So if same tree, remember, if same tree, I will simply pass all, both the roots, both my roots. I will pass the root, basically I will pass the root and the subroot in same tree, right? I will pass it, and if it is like, if it is returning true, okay, if this condition exists, I will return true. If this is false, I won't come under this condition, right? I won't come under this condition. And what I will do, I will say return, right? Return the same function, right? Let's do the same function. Do all these things same, right? Exactly same. Again with the root dot left. Maybe you will get some answer, right? So I will calculate with the root dot left or subroot, right? And subroot. Or it can be possible that is not present in the left portion, maybe present in the right. So I will say is same tree root dot right with subroot. Remember always that I am mentioning here or condition. Either this can be true or this can be true. Any one of is true, right? I will return true. Okay. So yeah, this will be your basically the pseudo code of this problem. Okay. In the next video, we will check the code implementation of this problem. So I will write the complete code of it. That will be nearly same, right? So I will write the complete code of it. Okay. So see you in the next video. And remember, that's a same tree, right? This is not your subtree function. That's the same tree. Okay. Yeah. See you in the next video.